Let's talk about ventilation. Okay, ventilation at rest after chronic exercise training. Increase, decrease, or stay the same. This one, ventilations are a little tricky.
Stay the same.
Stays the same typically. Okay, typically, in most people, it would stay the same. What about during submaximal exercise? Think about it logically. After training, you go out for an easy jog, your breathing is less, it's reduced. Okay, so after chronic training, submaximal exercise, your breathing is going to be slightly less, go down. But what about during maximal exercise? It actually goes up. It's increased. Maximal exercise ventilation is higher after training. Okay, let's talk about blood adaptations with training. What happens to total body blood volume after chronic training? Increase, decrease, stay the same. Increases. Okay, how many, just as an aside, how many, what's a typical lung volume, or I'm sorry, blood volume, typical blood volume for a normal sized individual?
5 liters.
It's about 5 liters, okay, and it can go up a fair amount with training, you know, as much as 10–20%. Okay, okay, let's split up total blood volume into different components. What about the total number of red blood cells within the body? Total number of red blood cell volume. Would it increase, decrease, or stay the same? It would stay the same or slightly increase. Stay the same or slightly increase. Okay, but what about plasma volume with training? Plasma volume will increase a lot more. It can go up as much as 15–20%. Okay, now with all those together, what about, let's say, a measure of hemoglobin or hematocrit after training? Increase, decrease, or stay the same? A measure of hemoglobin or hematocrit. They would actually go down. Okay, and this can be confusing to some people. Is the total number of red blood cells in your body lower? No, we said it's the same or maybe even slightly increased. But hemoglobin or hematocrit measures will actually go down. And why would they go down? Because the plasma volume is so much bigger, it basically dilutes it down a little bit. Okay, so it's a little more diluted down. So because of that, it goes down. Let's say the athlete after training, are they anemic necessarily? No. This phenomenon is called pseudoanemia or runner's anemia. And again, it's due to training. Okay, let's talk about VO2 lactate threshold economy changes with training. Not much really, not too much on the test with that. But obviously after chronic exercise training, we would expect to see VO2 max would increase. We'd expect to see lactate threshold increase, occur at a faster pace. Running economy sometimes will stay the same or sometimes it'll improve. If running economy improves, that means VO2 at any pace would be higher or lower if running economy improves. It would be lower. If economy improves, VO2 would be lower at any common pace. Okay. Factors that affect the response to training. These were more the global issues that I talked about, things like individual differences. What's probably the #1 factor that affects training? What's the #1 factor that typically affects anything in your body? Genetics. Genetics is usually the #1 factor that's going to affect the response to training. But there's individual differences. Some people are simply responders or non-responders. The quality of training, the intensity of training, the quality and volume of amount of recovery can also affect the response to training. Okay, we didn't go too in-depth in those. There might be just one question perhaps on that. But questions about cardiopulmonary adaptations to training. Do all those make sense? Biggest thing to focus on are these first, 4 right here. Vascular metabolic adaptations to training, cardiac adaptations, respiratory adaptations, and blood adaptations. There's going to be several questions, like on the other test, increase, decrease, stay the same, and make sure you know which way those go. Questions? Okay. All right, let's try supporting physiology. Thermoregulation and heat acclimatization. Let's list, first off, what are 2 ways the body can gain heat? 2 ways the body can gain heat. Well, let's talk more global. metabolism would definitely be one. Okay, remember the body's chemical processes aren't 100% efficient, so you're always going to produce heat as a result. And then you can also gain heat from the environment. So you can gain heat through your body's heat production, also through the environment. If we were talking in physics terms, what are the 4 ways the body can lose heat? Convection is one. Conduction. Radiation. Evaporation. Okay, in terms of physics, those are the 4 ways the body can lose heat. Can you also gain heat through some of those mechanisms as well? Could you gain heat through conduction?
Yes.
Yes. Could you gain heat through convection?
Yes.
Give me an example of how you could gain heat through convection. What if the air temperature was greater than your body temperature? Say it was a windy day in Las Vegas and it's 115 outside. Would you gain heat through convection? Yes. What about radiation? Can you gain heat through radiation?
Yes.
Yes. Go stand out in the sun. You'll gain heat. What about evaporation? Can you gain heat through evaporation? No, you can only lose heat through evaporation. Of those mechanisms, which one contributes the most to body heat loss at rest? Radiation. You lose more heat through radiation at rest. What about during exercise on a normal day? Normal conditions, like today. How would you lose most heat? During exercise, through evaporation would be number 1. Is there a situation where you could not lose heat effectively through evaporation? What would the environmental condition have to be?
Cold.
Not cold, it'd have to be very high humidity. Okay, when the humidity is very high, you can't, the air is saturated with water vapor. So you can't really evaporate water off your skin into the environment to lose heat through that mechanism. Okay, so if it's a very, for example, if it's an extremely humid day, what mechanism are you probably now going to lose the most heat through during exercise? What would you guess? If it was 100% humidity, now you're going to lose the most of your heat during exercise through what mechanism? Convection would be the number 1 way. If it's a really humid day, you better have a fan in your apartment, right? To help keep you cool. It's really humid. Okay, let's see. What are the ways that the body can actively control temperature? Okay, those were physical mechanisms. What are the actual ways the body can physiologically control its body temperature? You could shiver. You can sweat. You can vasoconstrict or dilate, change the radius of blood vessels. And then the other one was called non-shivering thermogenesis. Okay, that involves usually hormonal responses that cause your metabolism to rise and fall. Remember that non-shivering thermogenesis. Usually it's thyroid hormone is the primary one we're talking about there. What are some negative physiological consequences of exercise in the heat? Negative physiological consequences of exercise in the heat.
Decreased blood volume.
Decreased blood volume, absolutely. Whereas most of the volume, when you sweat, where does that volume come from? It comes from plasma. So if you decrease your blood volume, what's going to be the physiological response to having a lower blood volume?
Increased plasma volume.
Well, no. When you have a lower blood volume, a lower plasma volume, what's a cardiovascular response now that you're going to have?
Increased heart rate.
Increased heart rate because why?
Increased stroke volume.
Because of what?
Stroke volume.
Stroke volume goes which way?
Up or down.
Yeah, it'd go down. And why would stroke volume go down? Because venous return and preload are reduced. So when you sweat and you lose blood volume due to sweat, plasma volume, blood volume due to sweat, you have less venous return and preload to the heart. So stroke volume goes down and heart rate at any given workload is going to be higher. Okay, why is it bad if heart rate's higher during exercise? Can your heart rate keep going up and up and up indefinitely? No, there's a limit to it, right? So you're closer to your capacity in that situation. So that's kind of one. What's another?